This question asks us to draw the arrow pushing mechanism for the acid catalyzed hydration of this alkene. The first thing that will happen is that water will get protonated by sulfuric acid. The oxygen on water will take one of the acidic hydrogens from sulfuric acid, and that will form H3O+. H3O+ can then react with the alkene. We'll take some of the electrons in the pi bond of the alkene. We'll protonate the alkene with the H3O+. We'll break this alkene, use these electrons to form a bond with hydrogen. The Markovnikov's rule says we'll form the most stable carbocation possible, so we'll form the carbon-hydrogen bond at this position, and the carbocation will go at the most substituted position. We could also show this mechanism, this step of the mechanism, with a bouncing arrow to make this a little bit more clear. We take the electrons in the pi bond and we bounce them through carbon number 3 to attack the hydrogen. This says that when we break the pi bond, the electrons stay with carbon number 3 to form a bond with the hydrogen at carbon number 3, and we take the electrons away from carbon number 2, leaving behind a carbocation at carbon number 2. So this will then form a new carbocation intermediate. Markovnikov's rule says that we'll form the most stable carbocation possible. Water will then attack this carbocation to form a new oxygen-hydrogen bond. We don't have any arrows showing the breaking of any oxygen-hydrogen bond, so oxygen will still have both hydrogens attached, which means oxygen will still be positively charged. Another water will then come along to neutralize the charge and form our final product. We'll do a final proton transfer step to the end for this reaction to form our final product. And our final product in this mechanism will be a tertiary alcohol. This is an achiral product. There are no stereocenters. Achiral. There are no stereocenters in this product, so this will be an achiral product. This will be the only product that we form for this particular mechanism.